Basically, I'm a field guy. I'm in the field every day dealing with problems. And I'm going to show you some of the things that happens in the trenches. This is a in to where you guys want to be. Doing it right first time is our goal. That should be your goal, gentlemen. Workshop overview. I'll cover standards, processes that we use, and your role, and areas needing improvement. This is a way we have challenged our inspectors. For you people that don't know, this is a key process objective. They're very stringent, and I suggest that you should, in your sections or in your companies, challenge your supervision. One of our KPIs, we have 2 of them, is to submit 85% of completed inspection reports to the requester, which is you, within a 12-hour period. That's what we try to achieve. And our other KPI is to achieve 90% of acceptance rate of class client inspections at first attempt. Gentlemen, in a nutshell, you have to get it right the first time. Don't hand it over to QC inspectors. We have roughly 350, 400 inspections a day on a 24-hour period. This is the way we challenge our guys, and we'd like you to do the same thing. Get your supervision in the tank. Don't send a request to QC. Come down, Kevin, and take a look at our work. We'll help you out, and we do. But please, we need some from your side, okay? Challenge your supervision. Look at getting some KBOs in your organizations. That will make my life a bit easier. And the rate of the work is coming into the yard, 350 inspections a day. Some days we're hitting 500. We need your support. This is one way you can help us. We have a policy in the DryDock. We at DryDock World are committed to provide a continual improving service designated to meet the changing times of our customers. That's quite a bold statement. That's from our managing director. And what we try to achieve is 100% customer satisfaction. The customer pays our wages. Remember that. People come up to me in the days when we're down having some discussion, and they ask me, what's quality, Kevin? As I said earlier, I've been around this business a long time. To me, quality is an intelligent effort, or just effort. That's all we're asking. We can get into this and that, argument stuff, but we want an intelligent effort from people. That's all we're asking. Sections of QC, we have 130 inspectors in the DryDock at the moment. 6 engineers on staff. I think there was a few presentations done today by my co-workers. And we cover all aspects of steel. Of course, we got steel inspections, welding, we got a pipe section, does test packs, line walks, electrical, mechanical, hull treatment, which covers paint, DFT checkings of the hull, corrosion, dimensional control. They have a good section in our QC. They do a lot of dimensions for you people and make use of them. They have a lot of new equipment, and you'll see in the displays down there what they can offer you. And of course, we have an NDT section, as my colleagues touched on it earlier. Typical duties of our inspectors. Dimensional checking, bevels on your butts, alignments, internal alignment, capping, gaps on your butts, uneven, excess, NDT documentation, traceability, touch base on that later, and of course, with you guys, we like to build a relationship. Okay? Nobody wants to come to work every day and argue and fight over trivial things. talk to our QC guys. Come speak to QC if you have problems. This is relationship building. You may ask how we do it. I make it a point once or twice a week to get to the vessels, meet the superintendents, meet the surveyors. We build a relationship, gentlemen. And when we're negotiating or arguing about different things, we all have the common ground to work from. So what we encourage you guys, we all make mistakes. We'll touch base on that later. Is be open. Don't hide mistakes. I don't want to go to a vessel and listen to the superintendent at 8 in the morning. How come this happened? How come that happened? That's no fun. Puts us in a bad light. And nobody needs that these days. So there's room for improvement there, guys. And above all, you see the bottom line there. We have the superintendent over here. We have the class over here. We have you guys there. QC is in the middle. You have to sell your work. That's what we have to do. Bottom line. This is a typical inspection request we receive from you guys. It's called Form 436 on a daily basis. This is part of our KPO, as I spoke about. Everything has to come into our office. Everything is recorded. And there's a daily report that goes out to all managers. Okay, we'll look at ways how you guys can filter into this system. It's called a field quality report. It shows all the inspections we do on a daily basis and the areas that we reject. This is good for us. This can find fault and where we need to focus. Okay, it's not meant to put blame on you people. That gives us a good guide where we need to focus in our next project. That's all this is meant to be. Okay, the managers in the different departments use this regularly, and we get good phone calls and we get some not so good phone calls, but it all works out in the end. That's why we're all here. Good, healthy debate. That's what we encourage. Don't always listen to the QC guy. We can be wrong. I make mistakes. He makes mistakes, but we all learn from him. That's all we want. This is a typical inspection. I'll just run through them quickly for you. This is a dimensional check on one of the blocks in the shop. This is a seat. One of our boys checking the bevel. Again, as shown on the drawing, he's just confirming. Using his cam gauge. Alignment checking. High-low on your pipe fit-up. Schedule 80 there by the look of it. Very important when you're doing that root pass. Hopefully you're using TIG. Again, checking gap. We try to achieve a 5 milli gap. It'll come up in your standards later. Again, lots of daylight there, gentlemen. Don't call QC down for this stuff. You know what you have to do. Scribe that seat. It's a windlass seat. That's what it was. Scribe it. Bring it, drop it down. Why are you giving us a 25 mil gap? It costs you money. A little bit of common sense. Visual inspections are done for back gouging, reinforcement, lock wells, and fillet welds, throat and a leg. Our guys do this on a regular basis. Back gouging, beautiful job. A little bit of carbon shown, a little bit of grinding, sharp edges, clean it up. Again, checking reinforcement. Again, we got a mirror checking lock wells, which I'll touch base on it later. Again, checking the fillet size. On the drawing, it shows you need a 7 milli fillet, 10 milli fillet, all according to the thickness of the steel. Checking your throat size, which all inspectors do. Again, we have a lack of penetration due to improper root gap. Okay? Pay attention to what's happening down there. Burn through. Why you call QC down for final inspection in some of these areas, I'll never know. Send your supervision into the tanks. You got burned through. I can't do nothing about it. You guys do the work. Okay? How do you expect us to sell this? What am I going to bring the DMV surveyor down here? Please put your blinkers on, sir, and sign there? That doesn't work. Okay? I can't send a ship out to sea in this state. And I don't expect our inspectors to say, yes, that's good. This is a wrong WPS was used. Forged steel. For you people who are looking at this, this is a railway tie. Big crack down the middle. Improper welding procedure. Again, gentlemen, this is where your supervision should play a role. This is no good when I take my inspectors in a tank. If I took the D&V surveyor down. Is this good, gentlemen? No, we don't need that. Housekeeping gives a good impression. Impression, when you go into these tanks, means a lot to these surveyors and the client. Okay, these guys know what they're doing. They don't need to go in and see this. And first of all, I don't know how you expect to see the welds when cleaning is not done. It needs some attention. Rule of thumb is, gentlemen, if you're using a 3.5 stick, multiplied by 2, 7 milli on a fillet. That fillet is about 15 mil, way too much on a 12 milli material. Nice weld, proper weave technique. Lock welds. Missing lock welds. In new build, this last few years, some of the DMV boys are here. They know what we're talking about here. It's hard to break a horse of old tricks. Everybody wants to start, they go in and they start running their electrode this way or wire. Gentlemen, we got problems when you do this. We got a start and stop point there. Okay? You're going to get a cavity in your weld. And over time, you'll get cracks in this steel, stress cracks. Okay? They may not sound much to you, but in 2 years' time, when the surveyor has to go into that tank, Kevin, we got a problem. What we try to push you people to do is start here and do a proper lock weld around the ends. Simple stuff, but it continues, especially in new build. That's what we need, proper lock weld. Poor backside root. Obviously, they never had enough gap. The guy is a night shift. It's always a night shift job. That a good gouging job? I asked the gentleman, I asked the supervisor what happened. Oh, I had no air pressure. Gentlemen, when you're doing gouging, the prime thing you need is air to blow that steel out of there. Don't come and tell the QC guy I had no air pressure. Stop the process. Do something about it. We got down that morning, there was 10 meters of this plate cut like that. 10 meters. The guy knew, the welder knew that he had no air pressure. Stop. Supervision should have stopped him. Cost you money. This is what we need. Keep a straight line. We're okay. What is traceability? I know my colleagues touched base on this morning. I have a little different interpretation. Right at the moment, we have two big conversions going on in the yard, Livorno and Alkena. These are 100% traceability. That means I have to log every welder that welded a butt or a fillet. Okay, these are some of the examples how we do it. And you may ask, why do we need it? Gentlemen, the rule of thumb is these ships sail out of here, something happens. It's traceability. You got to jump back in, find out the process you were using, which welder he did it. I think my colleagues mentioned this morning, we need to go back through the system. Maybe we can improve your welder. Okay, traceability, gentlemen. Remember, it's a life history. The ship comes in here, gets a piece of plate put in, sails away. Documentation, 21st century. Something goes wrong when it's in the North Atlantic, as I showed you earlier. We have to prove that we did the proper processes. It's just like when you're born, you get a certificate, and when you die, you get a certificate. It's full traceability. This is some of the examples, how we do it. WPS 94 and the welder's ID and the date welded. Okay, this is all logged on the drawings. And they're given to QC for documentation. Some more typical examples. Notice the marks are on the butts, no weld. I guess there's another piece coming in there. So you try to get all the details. Here's fillet welds, gentlemen. Look, this is obviously, nobody could do any good planning here, but they got all writing all over the plate. This is fillet welds, okay? We need this. Traceability, gentlemen. When we ask you, when you ask me why we need it, these clients request it. It's in their specifications. They're paying for it. Some more examples. Some of the pipe identifications. Again, you notice the NPI done, checking the welds, which is again Some of these class 1, class 2, class 3 pipes, some of it is 20%, some of it is 100%. MPI, dye pen, or X-ray. Okay, all our engineers have that organized in their planning schedules, typical markings, and this is one unique way. You may ask, why am I showing you this? Okay, this is one of the plates we use to identify our spool pieces. Why we don't use cardboard? These pipes are usually blasted, and this is what we find that works well for us. Okay, simple. Think about it. I know I did a lot of inspections off-site this year. People are still using cardboard tags, and we had to blast a pipe. Think about it. Here's some of the coating systems they use in the pipe shop. I stand to be corrected here, but I think yellow means is ready for NPI or dye pen, and the green means is ready to go out of the shop. Coating systems, some things you guys can dream up, as one of our presenters said there. Make it simple. And you may ask why we have to make sure all our procedures are in place. This is one of the clients right now checking a qualification pipe on a piece of copper nickel, 9010. See, he's going with the mirror, checking the butt in there before we even present it for X-ray, qualifying our welders in the shop right now. I think this is on the Laverno, if I remember correctly. This is last week. Oh, so you may ask me why I'm showing that. Gentlemen, we run across unique things in the dry dock. Last week I was in the shop, stumbled on this. This is a heating coil manifold. We try to do it in lump sum, put it in a jig. These are, as my colleague said this morning, a lot of brazing techniques, but there's a lot of work involved to get this pipe in situ and pressure tested before you put it on board. If you don't enjoy your work on a daily basis, you spot unusual things, you shouldn't be into this business. This caught my attention last week. As you can see, it looks like an organ. If you guys know what a pipe organ is, very unusual weld went on there, very unusual. And here's some of the modules, as I told you, we're doing right now in the shop. Heating coil, piping, done as a box section, and put a board, tied in. And traceability, gentlemen, and my colleagues did a presentation this morning. This is our stockpile of plate. Everything is numbered, ABS, DNV. This is a unique thing that we introduced here years back when I think we first came in the yard. We're trying to bring it back up again. Red means something to QC. Anybody can tell me? That means grade A plate, gentlemen. We color code. Going to the shops, it's hard to, what type of plate is that? Okay, that means it's grade A. Green means it's 36. That's the most common plates we use in a dry dock at the moment. Now I'll jump into NDT. Non-destructive testing. It's a large part of our NTT group. As I said earlier, these ships come in for steelwork. How do we prove that they're seaworthy? This is what we do. Non-destructive testing. All our people are qualified. Vacuum box, penitent testing, MPI, mag particle testing, ultrasonic, and radiography. Typical examples, vacuum box in use, penitent testing, magnetic particle inspection, and ultrasonic testing. We try to encourage the ship owners to do more UT rather than RT. Okay? The equipment they have these days is sound. The operators know their stuff. In fact, the 2 rigs we built here last few years back, the Acker series, I think some of the DNB boys are here. They had people from their group, the Acker group, verifying our technicians, which worked both ways. That gives them confidence in our team, and they were confident they were getting a good product. Okay? That's why we have to do NDT, and it's good to see the client cross-checking us. That gives us a good name. That's why we'll get more of these rigs in the future. Typical radiography. Why do we do NDT? I think Sergeant touched base on this earlier today. We have to prove the integrity of the welds. I don't want to sign a document. I'm sure the surveyors won't sign any documents till they see the film. We want to be sure these ships, there's nothing going to happen to them when they leave here on a collision bulkhead, watertight bulkhead, on the shell. Prove the integrity of the welds. Prove the integrity of the material. If a ship breaks in 2 pieces, as you've seen today, we're all responsible. Just think about that. It's not QC's responsibility. Gentlemen, we're all responsible. I don't want that on my shoulders. If a ship goes outside the Gulf here, all of a sudden there's a big crack in a bulkhead. It's no good for anybody. Loss of business. Porosity. Can I have the board? Gentlemen, I want to spend a couple of minutes on this, okay? Last year, we did, I think, so far in the last 6 months, we did 250 x-rays. I like to stick onto this for a few minutes because out of that 250 x-rays, with your group, subcontractors, I don't want to get into the names and everything here, we had porosity problems. 250 x-rays, 40% failure rate. Out of that 40%, porosity was the cause. Everybody, I assume you know what it is. It's all gas pockets. Okay, this is what it looks like. Wormholes from the old school. We all know, you should know this, gentlemen. This is very important. Can anybody tell me what the major cause is of gas or porosity? Air inclusion, I'll class that down here. Elements, we class that. Elements can be wind, which is air, can be water. In this country, dust. My country, snow. Gentlemen, number one. Coal electrodes, number one. What else? Think about it. What else causes this? Any welding supervision out here? Mr. George? That's right. Adjust your machines, gentlemen. I can go on, but it can be operator error, adjust your machines. But gentlemen, I won't take much more time on this. Coal electrodes is number one. You hit the nail on the head. Give this guy a prize. We all have a part of this. How you control that is up to you. Right in here. You can control this process. Not Kevin, not our QC guys. You have supervision. Get into these ships. I know some companies have introduced vacuum packed electrodes, but we still have a problem with other companies with coal electrodes. We can go there any time of the day or night and find this problem. Coal electrodes needs to be looked at. Remember, 40% of your x-ray failures this first 6 months of this year was caused by porosity. And if we get that down, gentlemen, cost saving to you is tremendous. I have to do the x-rays. Surveyors feel safe that we're doing x-rays. Everybody will be happy. Electrode handling, number one. Coal electrodes, elements, welders, adjust your machines, and proper cleaning. I don't know how many people use wire brush here. In my country, one of the first things I had to do when I was getting my qualification, I had to have a wire brush, stainless and a regular wire brush. Just look at some of your welders down here and you got a dirty weld. You got humidity in this country. Use the wire brushes, please. It saves you a lot of time. This comes with experience, believe me. Simple, but effective. We use a baking oven in a dry dock. Okay, baking temperature, 300 to 350 C. You should have that on site. You should bake your electrodes. I know you guys just use the holding ovens, but I never see many people baking them. This is the holding oven, 90 to 150 C. And make sure the gauge is calibrated and have the certificate when the boys are doing audits. Welding quiver, make sure they're plugged in. Right, boys? Yes. Good? We find this in the tanks, gentlemen. You can find it any day. Good? Look at the gap there. They're going to have a field day on that gap, huh? That was on one of the rigs. You see, stumbled across this. I said, what are you doing, boys? Uh-oh. No good? These are rod carriers, gentlemen. They're not quivers. Please. No good? And, of course, here you're welding on a gypsy wheel. What do you need on a gypsy wheel? Casting. You need preheat, gentlemen. There's water. Okay? And coal electrodes. You're going to get fractures. You're going to get hairline cracks. Simple stuff, but people overlook it. Supervision. Here's a process happening. Using ceramics for you people that are looking closely here. Went up on the deck. Here there's water. What does water do? Cracks, gentlemen. Okay, I'll jump into the standards now, and I'll just touch base on a few of them. Here at the dry dock, we have introduced a set of standards for everybody's benefit. I think through our weekly meetings and monthly meetings, you guys have all received them by now. You should be getting this information to your workforce. These standards come from IACS, International Association of Classification Societies, DMV, ABS, Lloyd's. They have agreed for us to use this. Here in the dry dock, it was a great initiative, and I think if you get the message to your people, your quality of work will improve. That goes on and explain why we use it. Structural standards from ISAC provides a guidance on shipbuilding quality standards for a hull structure. The standards generally applies to conventional ship types, parts of the hull covered by Rules and Classification Society, hull structure constructed from normal and high strength steel. Generally does not apply to special types of vessels, which require more stringent standards. In this standard, both a standard range and a limit range are listed. The standard range represents the target range to be met in a regular work under normal circumstances. The limit range represents the maximum allowable deviation from the standard range. Work beyond the standard range, but within the limit range, is acceptable. This is what we use, gentlemen. I'm sure you all have copies of this. Okay, I think our QA boys have it on record. Get the information to your people. Okay, and again, if we make mistakes, refer to it. This is a typical standard. Boys with a straight line, assuming is a 1 meter piece of plate between two frames. Standard, we try to achieve between 4 and 6, 7 millimeter on a shell plate, tank top, bulkhead strength, and we have limits. Anything outside that range, no. Again, as I said in the first part of my presentation, come to QC, discuss these things. These are only guidelines. Misalignments at fillet wells, that's a no-no, but we can calculate the formula. There's room for play there. Okay, what we try to achieve, if you get half of that, you'll be all right. Again, this is unacceptable. Misalignments. Again, on a girder, you have to get the web closer for alignment. Bulb bar, unacceptable. A couple of examples. These are listed all in your standards, gentlemen. Distance between butt wells and fillet wells. D, a butt well and a fillet well, 10 millimeter. Basically, it's pretty small. You got to remember, 2 wells can't touch. That's all you got to remember. Again, on a girder between decks, 6 millimeter. Corrugated bulkheads, we have our limits. You're going to see IACS in there, AWS, ABS, what the rules are. Basically, it's 3 milli on the corrugation. 10 meter length. I'm on a longitudinal girder. We're allowed 10 millimeter. On a T-joint, T-bar, again on a T, 10 meter length on the straightness of the plane of a flange and a web. Angle bar, flange and web, plus or minus 3. Again, on your squareness of a piece of plate in the shop, D and D2, your axis in the middle, you're allowed basically 2 plus or minus 2. Tolerances for linear dimensions, all listed in the book. Fairness of plating between frames, it's all listed. Standard and limits were allowed. Fairness of plating with frames, this means fabricated panels. Again, roughness on the edge. When you're burning, you got a burner down there that's got a hard knife or a shaky hand. You have to give it a little rub with the grinder, gentlemen. Okay, 1.5. You get it down to that, we're doing pretty good. Again, if you have gaps stipulated in your books, anything over 25 mil, you need an insert. Okay, but we have some rules we can play with. Speak to the QC guys on board. If you have problems with interpretation, do not hide it. Different V butts, backing strips we can use. We have procedures. Position of scallops, Always seems to be a big discussion. It's all in your book. Heating of plate. Temperatures are all listed for conventional processes. Different types of material, D32, D36, AH36. Please follow the rules. Distance between butt welds and an insert, 300 millimeter. Distance between butt welds and cutouts, 30 millimeter. Distance between butt welds and cutouts, we just showed you that one. Distance between a butt weld and a fillet weld can be plus or minus 5 in certain locations. And again, pittings in the tanks, I don't think you guys get involved in this. We do mapping in the dry dock when we have to do pittings, and we have a procedure in-house. It's all listed there, the depth, what you have to do. Butt welds, undercut, this is a big one for us. Gentlemen, anything over past 1 milli, we have to weld. You may say, oh, I get phone calls all day long. Kevin, it's undercut. I said, well, you have to run a bead of weld on it. This is an area that we focus on because it's prone to cracking. Irregularity of manual welds, 3 millimeters the limit. Grinding, we have to take sharp edges, and you may ask why. Steel shop fight this one day in and day out because of the coating systems, gentlemen. The $1 million coating systems they're putting into these tanks right now, and the paint will break down if you don't take sharp edges off. Allow for that in your quotes. Scallops, weld seams, it's all listed there for you. Okay, conclusion, gentlemen. 35 years in this business is amazing what you run across. There's been some good discussions, and I encourage this. You need to be part of our team, guys. We need to share information. Some of my presenters here today, or some of the presenters, we need you to be part of our team. This is the way forward. But if you got problems, ask questions. Discussions are healthy. It releases some of your frustrations you have with your people, and it gives us the way to barter back and forth. You know, I mean barter is healthy discussion. It's good to have an argument with the QC guy. Then we all walk away and shake hands. The job gets done. Okay? But we learn from our mistakes. You know, like I said, we all make mistakes, but learn from them. Don't repeat it again. And KPOs should be a part of your quality system. Challenge yourselves. Grow together. It's the foreman's duty to go into the tanks and check before offering QC. You don't want my QC inspectors going down into the tanks and offering rejections. That's no good for you. Reject. You as a manager, oh my God, what's wrong with this company? Okay? We do workshops in QC to help you people. Make use of it. If you need an area for us to focus, let us know. We have enough engineers in our section. I think we can put on a course for you people. We encourage you to do that. Your people have to grow. They have to learn. Don't come to me and say, oh, Kevin, they're from Fish Market. Gentlemen, we have these people. We have to train them. You have a prime opportunity in the dry dock. I think it's the only company in the world that gives free training. You come into QC. We can help you out. Thank you, gentlemen. That's all I have.